All right, welcome to the deep dive.
So we've all seen the movies, right? Giant asteroids hurtling towards Earth, and the fate of humanity hanging in the balance. It's a pretty captivating thought, but also kind of terrifying. We're diving into that today. Looking at the possibility of asteroid impacts, how real that threat is, how we even find these things in the vastness of space, and what we could actually do to protect ourselves.
Absolutely. It's one of those topics that grabs your attention, no doubt about it. And it's definitely worth exploring beyond just the Hollywood version.
Right. We're going beyond the special effects and the dramatic music. Let's get into the actual science of it. And to kind of kick things off, let's start with a fact that might surprise you. Did you know that Earth is constantly being bombarded by space debris? We're talking about 100 to 300 tons of meteors every single day.
Yeah, that's a pretty staggering number when you think about it.
It is. I mean, it's mostly tiny particles like dust and little pebbles burning up in the atmosphere, those shooting stars we see. But it does make you wonder what else is out there, the bigger stuff. Well, that's where asteroids come in. Essentially, they're the leftovers from the formation of our solar system about 4.6 billion years ago. All the rocky material that never quite made it into a planet.
Okay, so like cosmic crumbs, basically.
Yeah.
Remnants from the Big Bang of our solar system.
Exactly. And those crumbs come in a huge range of sizes.
Yeah, when we say asteroids, what kind of sizes are we talking about?
It's a vast spectrum. I mean, some are as small as a car, maybe even smaller. And then you have some that are absolutely massive, hundreds of kilometers in diameter. I mean, we're talking like bigger than some countries.
Wow, okay. That's a huge range. And how many of these asteroids are out there floating around?
Well, we've cataloged over 1 million so far, but that's just the ones we found, right? And of those, about 26,000 are what we call near-Earth asteroids.
Near Earth, so they're like our neighbors in space.
Basically. Their orbits bring them, relatively close to Earth, and out of those, about 2,000 are classified as potentially hazardous.
Okay, potentially hazardous. That sounds a little concerning. What makes them hazardous?
Mainly their size. If an asteroid is large enough and its path intersects with Earth's orbit, well, that's when we start paying very close attention. We've actually identified 158 asteroids that are larger than 1 kilometer in diameter.
A kilometer, that's pretty big, right?
Yeah. To put it into perspective, that's like 2.5 times the height of the Empire State Building. So yeah, we definitely don't want those hitting us.
Right. I think we all intuitively get that a big asteroid hitting Earth would be bad news. But do we actually have evidence that these kinds of impacts have happened before? I mean, besides those cool sci-fi movies.
Oh, absolutely. Just look at the moon. It's covered in craters, right? All those are from asteroid impacts over billions of years. Earth has been hit countless times too, but because of our atmosphere and all the geological activity, erosion, plate tectonics, a lot of the evidence gets wiped away over time.
So Earth has a way of kind of healing itself.
Yeah.
In a way. But we do have records of some impacts, right?
Yeah, we do. The biggest one in recorded history, the one that really sticks out, is the Tunguska event. This was back in June 1908 in Siberia.
Tunguska. Yeah, I've heard of it. It always seemed like a bit of a mystery. What exactly happened there?
Well, something big entered Earth's atmosphere, maybe an asteroid, maybe a comet fragment, we're not entirely sure, and it exploded over Siberia.
Exploded in the air?
Yeah, before it actually hit the ground. And the energy released, it's estimated to have been equivalent to about a 12 megaton explosion.
Whoa, that's huge.
Yeah. It flattened about 80 million trees over an area of like 830 square miles.
Wow, 80 million trees. That's mind-blowing. So that was in 1908, so pretty recent, all things considered. What about further back in time? Have there been even bigger impacts?
Oh, yeah, way bigger. Researchers at the University of Arizona, they estimate that Earth has been hit by, get this, up to 3 million asteroids larger than a kilometer in diameter throughout its history.
3 million. That's a lot of asteroid hits.
It is. And the biggest ones, the ones that were hundreds of kilometers across, those are harder to find now. Like I said, Earth's good at covering its tracks. But there is one impact, a really famous one, that left a mark we can still see pretty clearly, and it's the Chicxulub event.
Ah, Chicxulub. The dinosaur killer, right?
Exactly. About 66 million years ago, a huge asteroid, we're talking probably about 10 kilometers across, slammed into the Yucatan Peninsula near the Gulf of Mexico.
That must have been one heck of an explosion.
It was. It's estimated to have been about 100 million megatons, and that impact is pretty much the reason the dinosaurs went extinct. It wiped out something like 75% of all plant and animal species on Earth.
Wow, so it basically reset life on Earth.
It did. I mean, if that asteroid hadn't hit, who knows what life would look like today? We might not even be here.
That's a pretty sobering thought. So knowing that these impacts have happened and they can be absolutely devastating, how are we trying to avoid a repeat of, another Chicxulub? It seems like finding these asteroids early is key, right?
Yeah, absolutely. Early detection is crucial. If we want any chance of doing something to prevent an impact, we got to know it's coming. And we got to know well in advance. That's where asteroid detection comes in.
So how does that work? I mean, space is huge.
Yeah.
How do we even find these things?
Well, it's a global effort. There are government-funded programs, grants for research and dedicated telescopes and things. But a lot of the work is actually done by amateur astronomers.
Really? Amateur astronomers are involved in this.
Oh, yeah, they play a huge role. I mean, think about it. These asteroids are relatively small, and they're really far away. Trying to find them is like, as one of your sources put it, looking for a charcoal briquette in the dark. It's a real needle in a haystack situation.
Yeah.
But amateur astronomers are out there scanning the skies, looking for anything unusual.
It's pretty amazing that these folks are contributing to such important work. But how good are we at finding these potentially hazardous asteroids?
Well, that's where things get a bit, challenging. NASA and other space agencies, they've actually run simulations of asteroid impacts. And in one pretty realistic simulation, they gave themselves 6 months of warning. And guess what?
They couldn't stop it.
Nope. None of our current technologies could prevent the impact.
So 6 months is not enough time.
Not even close. That's why the focus is on finding these asteroids years, even decades in advance. If we have that kind of lead time, then we have options.
Okay, so what's holding us back from finding these asteroids sooner?
Well, right now, we estimate that we've only found about 1% of the near-Earth asteroids that are big enough to cause, serious damage on a global scale.
Only 1%.
Yeah. We've found a lot of the bigger ones, the ones that are easier to spot, but there's still a huge number out there that we haven't found yet. It's like we're just starting to scratch the surface.
Okay, so we're looking, but we need to be looking a lot harder and a lot sooner. So let's say we do find a big asteroid heading our way, and we have, a few years to prepare. What can we actually do to stop it?
Well, there are a few ideas out there. Some are more, sci-fi than others.
Okay, give me some examples.
Well, there's the kinetic impactor, which is basically just ramming a spacecraft into the asteroid at high speed to try and knock it off course.
So like a cosmic billiard shot.
Exactly. Then there's the idea of a gravitational tractor, which would use a spacecraft's gravity to slowly tug the asteroid away from Earth.
Okay, a little more subtle. What else?
There's also the nuclear option.
Like blowing it up?
Well, it's more about nudging it off course with the blast, not completely destroying it. But yeah, it's a bit more extreme. And then there's some more, out there ideas, like using lasers to vaporize parts of the asteroid and create thrust, or even painting the asteroid white to increase its reflectivity so the sunlight pushes it away.
Painting it white, that's a new one. So out of all these options, which one is the most, realistic? The one we could actually do with current technology?
Right now, the kinetic impactor is the most promising. It's basically using the technology we already have for spacecraft, just on a more impactful scale.
Pun intended.
Maybe, but the idea is that even a small nudge, if you do it early enough, can make a big difference in the asteroid's trajectory.
So it's about diverting it, not destroying it. And we've actually tested this idea, haven't we? With the DART mission.
You got it. The double asteroid redirection test. NASA launched it a while back specifically to see if we could actually move an asteroid with a kinetic impactor.
And the target was Didymos, right? That asteroid system.
Right. But just to be clear, Didymos is not a threat to Earth. It's a binary system, meaning it's a larger asteroid with a smaller moonlet orbiting it called Dimorphos. And DART was aimed at Dimorphos.
So it was a controlled experiment, basically.
Exactly. In September 2022, DART slammed into Dimorphos at a speed of about 6.6 kilometers per second.
That's incredibly fast.
Oh, yeah. And the goal was to see if that impact could change Dimorphos's orbit around Didymos.
And did it work?
It did. They measured a change in Dimorphos's orbital period, a decrease of about 10 minutes. It might not seem like a lot, but over time, that tiny change in velocity can add up to a significant shift in the asteroid's path.
So we can actually move asteroids. We have proof of concept.
We do. It's a big step towards, being able to protect ourselves from these potential threats.
That's reassuring in a way.
Yeah.
But what's the current situation? I mean, are we in any immediate danger from a big asteroid?
Right now, based on what we know, there are no known asteroids larger than 140 meters that have a significant chance of hitting Earth in the next 100 years.
Okay, that's good to hear. But didn't you say earlier that we've only found about 1% of the potentially hazardous asteroids?
That's right. So while there's no immediate danger that we know of, that doesn't mean we can just relax. We need to keep looking, keep finding these asteroids so we're not caught off guard.
So the search continues.
It has to.
Okay, so let's wrap this up. We've learned that asteroids are leftover bits from the early solar system. They come in all sizes, some really big, and Earth has been hit by them many times throughout its history. Those impacts have had a profound impact on life on Earth, literally. But we're not just sitting ducks anymore. We're actively searching for these near-Earth asteroids, and we're developing technologies to deflect them if we need to.
Yeah, it's an ongoing effort, and it's definitely a global one.
Absolutely. And while the thought of asteroid impacts can be a bit unsettling, it's amazing to see how much we're learning and how proactive we're becoming in protecting our planet. So on that note, here's a final thought for our listeners. We talked about the Chicxulub impact, the one that wiped out the dinosaurs. But what other cosmic events, maybe not as dramatic as a giant asteroid, could have shaped Earth and life on it in ways we don't even fully understand? It's a pretty mind-blowing concept to think about. Anyway, thanks for joining us on the Deep Dive.
It's been a pleasure. Always great to talk about this stuff.
Until next time.
Thanks as always for watching today. And if you like our videos, please don't forget to click on the like button and comment in the comments section. And if you already haven't done so, why not subscribe? It is completely free.